I will begin. All right, everybody. I will begin with a word of prayer, and then I'll take your question, whatever that is. Yeah. Heavenly Father, we thank you for this day. Thank you for these students. Again, I just pray you be with us today, guide our steps, help us to make the most of the time we have here for your glory, Lord. In your name I pray. Amen. What was your question? While I'm top hatting. Okay. What are you saying? Let's see here. 3:15, right? All right. 1575 is the top hat. 1575. So are there any questions about anything before I get started? Today I have, so I think what I'm going to do to start with here is show you another example, the kind of thing we were doing last time. All right, so here it is. This one's going to be a little bit uglier because this one we're not going to be able to factor so nicely. So here we go.
Wait, what kind of problem is this?
What?
What kind of problem is this?
Nonlinear inequality. So it's kind of more of what we were doing at the last class. So here we go, x squared plus 3x minus, 8 is greater than 0. Let's try to solve this problem. So notice that to start with, we can't factor. It doesn't factor nicely. You can try, but it won't work. So pretty much, we're going to need to use completing the square to factor. So what we're going to do is we're going to take half of 3, all right? Take half of 3, which is 3 halves, right? We square that. And then, as we discussed, in order to be fair, we have to subtract the square of 3 halves, right? And then, of course, we still have the minus 8. So what I'm underlining in blue right here is identically equal to these two terms, right? So this is completing the square. Take half of the term, half of the coefficient of x, you take x plus that, you square it. You have to subtract the square of whatever goes here, over there, all right? Now what? Well, here we've got x plus 3 halves squared, all right? And then what? Minus 9 over 4. How many fourths is 8? Is 8? 30, yeah, 32, right? 32 over 4. So we can combine these, right? And we get x plus 3 halves squared minus, what is that, 41 over 4 greater than 0. Now, use your imagination here. We want to rewrite that as the square root squared of that. Reason being, right, that we can factor using the difference of squares formula, right? So this factors to x plus 3 halves, let's say plus the square root of 41 over 2, or x plus 3 halves minus the square root of 41 over 2, greater than 0. Now, we didn't have to work that hard at the examples we did last time, because the last time, the examples we looked at, they just factored nicely, right? But now this one, I kind of have to work a little bit to factor it. Now once I do that, I can see what the critical numbers are. right? What are the critical numbers for this expression? Remember, critical numbers were numbers that either made it undefined or 0. Here, the critical numbers are minus 3 plus or minus the square root of 41, all divided by 2. All right. Now let me just pause for a second here and explain what I'm doing and give it a label. All right. This technique I just used right here, this business right here, this is called factoring via completing the square. So if I ever ask you on a test or a quiz or something to factor by completing the square, this is what I'm talking about. All right. Yep.
So,
Okay.
no, wait, never mind. I'll wait.
No, you ask.
I was going to ask, is that the answer?
Oh, no, we're not there yet. So remember we had that 4-step program, the roadmap. We are now at step 1. We've identified the critical numbers. All right, step 2 was to draw a number line with the critical numbers on it, right, in order. So here's step 2. And one of the things that I didn't do last time that maybe I should have because it's good practice is to write the expression which the number line is describing to the right of the number line. That way I know I'm telling my reader values on this number line here have to do with this expression. And so the numbers are minus 3 minus the square root of 41 all divided by 2, or minus 3 plus the square root of 41 divided by 2. What's another way you could have found these algebraic critical numbers? Yeah? The quadratic formula. Very good. Yeah, we could have done that. But I wanted to show you how we could factor it using this, okay? Because there will be problems where you want to be able to factor when it's ugly, and this is how you do it. All right? All right, so then what? That's step 2. Now, step 3 was we want to add pluses and minuses as appropriate, right? So we want to test points and add plus or minus depending on whether the expression is positive or negative. An easy thing to check is 0, right? Because this is a negative number. And this is actually positive, right? Because the square root of 41 is bigger than the square root of 36. The square root of 36 is what? It's 6. So like 6 minus 3 is 3. So this is definitely positive because square root of 41 is bigger than 3, right? Anyway, so this is positive, this is negative. 0 is somewhere in here. What's the value of this expression when you plug in 0? Plug in 0 here, what do you get? Negative 8, right? So it's negative here. Then notice that each one of the factors is what? It's just to the power 1, right? They're both odd powers. So the sign flip theorem says that we change from minus to plus as we go across the critical numbers. All right. Now, so we've completed step 3. Now step 4, we write down the answer. Yep.
I'll be honest, I still don't understand like the plus and minus.
I'll do another example then.
How do you know they're even or not even?
Power 1. Odd. These are odd powers. Yeah. But since there's questions about this, I will show another example which has more to sink your teeth into. There's not enough in this example to really expose nuances in your understanding of this issue. So we need an example that's got more bells and whistles. All right. Let me finish this one. So we're looking for greater than 0. So we're looking for pluses, right? And strict inequality, so we don't include the critical numbers. We don't want where it's actually 0. What we got then, solution set, a little bit ugly here, but here it is. Minus infinity all the way to minus 3 minus the square root of 41 over 2. Union minus 3 plus the square root of 41 over 2 to infinity. That's it. That is it. I'm going to come back to, yeah?
Could you skip doing the number line with the pluses and minuses and just go straight
if the problem's simple enough and you remember how it works for another one, but I want you to write the number line. There are ones that are more complicated that the number line is going to be needed. The one, example 3 will be like that. This one's going to be silly, okay? So I'm not really answering your sign flip question just yet. But here's something we could try on for size. X squared plus 6x, I don't know, plus 11, less than 0. And let me make it a minus 6x just to make it more, well, maybe we can solve it, right? So we complete the square. I have x minus 3 squared. I have to subtract the square of 3, which is 9. So what we get, x minus 3 squared plus 2 is less than 0. So at this point, I don't think I would say like this one. I don't think we need a number line for actually. All right, because in this case actually, there is no critical number. There's no 0. Well, the zeros to this quadratic equation, if you were to set it equal to 0, they're complex. All right. But here's just common sense. If you look at this, this is always bigger than 2. Well, unless what? Unless x equals to 3 and it's 2. Right? If I plug in 3, I get 2. But otherwise, if you look at it, we're taking a square of something, we're adding it to 2, right? So 2 is the smallest that gets. Can that be negative? If 2 is the smallest it gets, can it be negative? No, it can't, right? So the solution here is there is no solution, so no solutions. Or, in other words, solution set is the empty set. If you want me to make this one more exciting, if we just, turn that less than to greater than, what happens? Right, example 3, we could solve it, right? Example 3, if we have x squared minus 6x plus 11 greater than 0, that says solution set is everything. Because of this calculation right here, right? Because x minus 3 squared plus 2 is always greater than 2 or equal to 2. If it's always greater than or equal to 2, it's certainly greater than or equal to 0. Let me write that down. So my point to you is it's common sense that x minus 3 squared plus 2, right, is greater than or equal to x minus 3 squared, which, by the way, is greater than or equal to 0. But actually, I can put a strict inequality there. So of course, x minus 3 squared plus 2 is positive. To put it in words, it's the sum of squares. Sum of squares can't give you something that's negative. At worst, it could give you 0 if both of the squares are 0. But that can't even happen here because 2 is in the mix. So the number line here is very silly because there's no critical number. Like if you were to do the number line idea for example 3, it just looks like this. Here it is, And then you check a point. It's not that this falls out of the roadmap. It's still very much on the algorithm we did. It's just different. I mean, there's no critical number, so we kind of skip step 2. We go straight to step 3. We test a point in each case, but there's only one case. So pick any point. Like 0. What happens when you plug in 0 into this? You get 11, right? So it's always positive. So if you want to solve x squared minus 6x plus 11 greater than 0, the answer is everything. All right. And that same number line would apply to example 2 to show you why the empty set's the solution, because there's never any point which makes this expression negative. None of this helps with your sign flip question. So here, let me make one that might help you with the sign flipping. How about this? We have x plus 1 to the 4th power, and then we have x minus 6 to the 3rd power, and then we'll divide by, let's say, x plus 10 to the, I don't know, square. Well, let me make it 5th power instead. That's more exciting. All right, there. And what do you guys want? Less than, greater than, equal to? Pick your poison. What do you want? Greater than or equal to. 0, right? That should be said from the outset. We're always taking stuff and comparing it to 0. Otherwise, we need to do algebra to make it like that. There may be some problems in your homework where you need to do some algebra before you can apply the roadmap, right? We can talk about those Friday. But what's that?
Multiply off the top by x plus 10.
Oh, no. So we definitely don't want to, like this is already factored, which makes it helpful. We can read from this the critical numbers. So yeah, do not multiply out. No. Critical numbers. I heard negative 1, 6, and negative 10, right? Remember, we have to flip the sign because, what makes x plus 1, what makes x plus 1 0 is minus 1, right? What makes x minus 6 0? It's 6, all right? So those are your critical numbers. And then we draw our handy-dandy number line here. And I'll put the thing I'm analyzing over here. I didn't use this notation last class, and yeah. It's better if I do. I didn't write this here, but it's a good practice to write this here just to remind yourself what you're looking at. Here, you're looking at that, yeah? Now which one comes first as we go left to right? I heard negative 10, negative 1, and 6. Okay, yeah. All right. So now we can plug a point in, figure out pluses and minuses. What would you start with, guys? Negative 2? Incorrect. You really can't be incorrect. I'm just joking, of course. But 0, there's something lazier. That's why you're not correct. 0 is always the laziest if you got it. The only time you can't use 0 is if what? If 0 is actually one of your critical numbers, then you can't use it. So we think about plugging 0 into that, right? Well, we got 0 plus 1 to the 4th, 0 minus 6 cubed, divided by 0 plus 10 to the 5th power. What are we looking at? We got 1. I'm just going to put it, what really matters is the sign, though. So we've got something plus. We've got minus 6 cubed is positive or negative? Negative, right. So we got plus times a minus, and we're dividing by a plus, right? So the net result of that is negative. So we got minuses up in here. All right? Now so now I'm going to use the sign flip theorem, okay? Sign flip theorem says you look at the critical number. In this case, let's look at 6. All right? What is 6? Why is 6 here? 6 is here because we have an x minus 6 cubed, right? That's odd. The power is odd. Not the 6. 6 is even, in fact, but the power here is odd, 3. The power is what matters. So 3 is odd. That means we flip from minus to plus going across that. All right? How about minus 1, though? Minus 1 is coming from this x plus 1 to the 4th power, right? That is an even power. That means, yeah, we stay. Stay minuses, yeah. right? How about minus 10? That's coming from this guy. Odd power, flippy flop, yeah. So we have pluses over here. Now, you see, everything I wrote with blue, we obtained from the sign flip idea, just propagating over. I only actually had to plug in 0, right? Now, you can check your work. You could try plugging in like minus 11 over here and see if you got it right or not, you know? But you don't need to. But if you wanted to, you could try plugging in like minus 11.
So whenever you plug the numbers, it doesn't matter what actual numbers you get. You just need to find out what sign is going to be.
Exactly. You're just after the polarity, the plus or minus, like which is it, positive or negative. The actual number here doesn't matter. It will matter in about 3 weeks or so. Once we're actually graphing, then we might actually want to know the number in order to get a sense of like where the point on the graph is. But at the moment, we're just interested in positive or negative because we're just solving these inequalities. There is a place where the number matters. It's just not here. All right. So what's that? Oh, OK. So what's the answer then? Now we read the answer, right? We want greater than or equal to 0. So it includes minus infinity. Solution set minus infinity to minus 10. I'm going to leave that ambiguous for a second. Union with 6 to infinity. All right, at least that. Now, do we include or exclude minus 10? Include or exclude? What do you guys think? What happens when you plug minus 10 into the expression? You're dividing by 0. That is not allowed. That can't be part of the solution, right? We have to exclude minus 10 because there's division by 0 there. How about 6? Right? Are we looking for 0 as a possibility? We are. That's something we're looking for. Equal to 0 is part of it. So yeah, we include 6. Square bracket. Now, is that everything? So I would give you 90% for the solution. You're missing one thing. Where else do we get 0?
In the plus 1.
In the plus 1, which is actually minus 1, right? So when we put x equal to minus 1, we get 0, which is a solution, right? So we have to union, this is kind of funny, with the set just containing minus 1. Now, I forget last time if we had any example where that happened for us in here. No? So it's happened for some sections. It hasn't happened for others. It kind of depends on just what we pick.
Would
Yep.
it matter if we put the minus 1 in between the 6 and the negative?
No, it doesn't matter. You can put those, the union of sets is commutative. Like A union B union C is C union B union A is B union A union. I mean, you can reorder the union of sets any which way you like. It's the same thing.
You don't have to like work another problem out loud. Just like on the top, if it was instead of multiplied by that, if it was a plus.
Oh, if it was a plus, then that's an unfriendly question.
Okay. All right.
Yeah, that.
Would we get one like that in this class?
Well, now that you mention it, that might be interesting. I mean,
Oh dear.
No.
Oh dear.
Why is it?
You shouldn't get it though, you know. You shouldn't get it.
Yeah.
you guys don't want to do interesting things?
Nah.
We've already done enough.
You paid good money for this class. You don't want to be challenged?
I want to be challenged.
You want to be challenged?
Nah, I want to get what I paid for, okay?
You want to get what you pay for? Well, I mean, just make a multiply become plus. How hard could it be, right?
How hard is it?
It could be very, very hard. If you change this multiply to plus, then that would mean you need to multiply out that quartic, and you multiply out this cubic. Then you'd have to combine like terms. After all that was done, you'd have a fourth order polynomial you had to factor, and it wouldn't factor nicely.
Leave it.
That is not something we ask you to do in here. Yeah,
Yay.
that's not something I ask math majors to do. I mean, unless I just want to punish them.
Do they do that in higher level algebra?
Well, so that's the question is like, your real question is how do we factor a polynomial of arbitrary order? Do you guys know?
Nope.
Like we've talked about how to factor a quadratic, right? We've talked about how to factor can you factor a cubic? How'd you do it?
Imaginary numbers.
Like there are pretty much only two ways that you guys typically can factor a cubic in here, right? What are those two things? Either is something like this, well, I guess there's three ways, or it's something like this, or it's something like this.
Is the x squared in the first one supposed to be a cube, or can we leave it?
Oh, that's supposed to be a cube, my bad. So this one is just like straight up x plus 1 cubed using the binomial theorem, Pascal's triangle, whatever. I don't think I covered that in here with you yet, so if you don't remember, it's all good. This one, on the other hand, we did. That's x plus 2 times x squared plus 4x, minus 4x, plus 4. That's that special trinomial formula, a cubed plus b cubed is a plus b times a squared minus ab plus b squared. Remember, day one. If you don't remember, that's why you have a formula sheet. We have a quiz next week, right? You better have that formula sheet ready. It is on Wednesday.
How long do we have on?
Whole class. The quiz is a pretest, so
How long do we have on tests?
whole class.
Are they like the same length as the quiz?
Yep. I try to make the quiz a little bit nastier.
How many questions is it?
I mean, they're similar. I don't know. Let me not commit to that. What's that?
How many
questions? There are enough questions. It's a good question. Let's see, x. Enough. Yeah. Yep. Yeah.
Why is that?
I mean, there will be enough questions. So my point to you is, in terms of cubics, that's kind of like it. In terms of nice factoring strategies. But quartics, we did like x to the fourth minus something. We factored that. But the truth of the matter is, for like an nth order polynomial, like higher order polynomials, there is no nice way to factor. It's just a genuinely hard problem. There is a formula for a cubic. There's a formula for a quartic. These have been known since like the 1500s, in Europe at least. As far as I know, those cubic and quartic formulas were not discovered by other cultures earlier. The quadratic's been known to a number of cultures, Indian, probably Babylonians even. The quadratic formula has been known since ancient times. But the cubics and quartics were discovered in Europe in the 1500s. And then from about 1600 to 1800, people tried to solve the fifth order problem, to find a formula for the fifth order, like a quadratic formula for a fifth order problem. It was eventually proved that it could not be done. It's impossible to write the solution for an arbitrary fifth order problem in terms of radicals. And this actually gave birth to what's called group theory. So group theory was invented in part by this French mathematician named Galois in like the 1820s. He died at age 19 from a duel. Might have been 21, I forget. But anyway, that's actually a lot of the math that's behind like how we think about physics today. You've ever heard of the standard model of physics? You know, bosons, like protons, neutrons, quarks, all that stuff. All of that is built over representation theory of groups, which actually ties back into the question of how do you solve the arbitrary fifth order polynomial, which is the same basically question as how do you factor a fifth order polynomial. These are good questions. They actually lead to very interesting results. But for this class, it's just this. Like, and we can factor quadratics. That's kind of it. Like, there's not nice stuff past that. It's just, it requires creativity, insight, some kind of, and there are numerical methods for approximating things. But all right, I am now way, way off track. Thank you, guys. But I'm happy for that. That's good. You guys had questions. Good. So let's move on, though. So the rest of class, we're going to be talking about absolute value. All right, absolute value. So let me remind you how we define it. Absolute value of x is the square root of x squared. All right. This is equal to plus or minus x. In particular, it's minus x if x is less than or equal to 0, and it's x if x is greater than or equal to 0. If you doubt me, let's try a number. How about the absolute value of minus 6? What happens? according to my formula, we have the square root of minus 6 squared, which is the square root of 36, which is, well, I think it's 6, right? Does that fit this case-wise thing I wrote up there? It does, right? Because that 6 is actually minus a minus 6, right? Just to show you how that works. Now, there's a temptation we have in mathematics, especially, I mean, I still fall prey to this sometimes. If I see minus x, I think to myself, it's negative. But is minus x negative? I mean, maybe, maybe not, right? It depends on it depends. If x is positive, then yeah, minus x is negative, right? But if x is negative, minus x is actually positive, right? So be careful with that. All right, so what can you tell me about absolute value? Well, here's one. If we have the absolute value of x times y, we can prove that that's equal to the absolute value of x times the absolute value of y. Right, so the absolute value of a product is the product of the absolute values. And well, if we know this, we can derive something else pretty easy. Absolute value of minus x, what's that equal to? That's absolute value of minus 1 times x, right? Which is absolute value of minus 1 times absolute value of x. What is the absolute value of minus 1? 1. So that's just absolute value of x, right? So therefore, absolute value of minus x is equal to absolute value of x. Yep.
Another way to say that is an absolute value of any number will always be the positive.
The absolute value of any number will always be the positive. Yeah, it's always the magnitude of the number. The distance from 0, very good. But yeah, I say it, I like to say this one somewhat more violently. I say that the absolute value eats minuses, right? It destroys them. If numbers were Vikings, it sends them to Valhalla. Whatever. Anyway, so what else can I tell you? There is one very important property of absolute value. I should not bury the lead here. Absolute value of x is greater than or equal to 0. So if you're ever solving an absolute value problem, right, and you're asked to make an absolute value negative, there's no solution to that problem. So that's just something to watch out for that. If you're mid-calculation and you get to absolute value is negative, stop right there. You're done. No solution. Yeah. So, example. Where are my example? Oh, example 5. I thought you were saying it's 5 o'clock. I was like, uh-oh. Time flies when you're having fun. No. Yeah. You just, where's the clock? It's 5 o'clock somewhere. All right, very good. Absolute value of, yeah. How about 15? All right, 15 x minus 7 equals to 2. 45. I'll put 45 in the next problem for you. All right, how do you solve this? There are 2 usual ways. I'll show you both.
So you do like, 15x minus 7 equals minus 2?
I can do, yeah, plus or minus 2. As I can use the plus or minus notation to do both problems at once. So this gives me, 15x is equal to 7 plus or minus 2. So x is equal to 7 plus or minus 2 divided by 15. So that means x is equal to 7 plus 2, which is 9/15, or x is equal to 7 minus 2, which is 5/15. Right. You guys want to, you want me to simplify them? Fine. 3/5 or 1/3. So there you go.
Yeah, good, buddy.
So we can solve an absolute value equation using plus minus notation. Now some of you like the plus minus notation, some of you don't. I don't require you to use plus minus notation, like it's up to you. Let me show you the other way.
Would it be easier to do that?
I don't know. It's like, do you want to spend 45 seconds on a problem or 30 seconds on a problem?
Something like 10.
I don't know. Oh, 45, right? So 45 minus, let's say 2x equals to 13. All right, let's solve this thing. I'm going to use the other method, which is to solve two separate equations. The two separate equations we have to solve are 45 minus 2x equals to 13, or 45 minus 2x equals to minus 13. Can you guys solve those? So you get it? You guys get it? Let me walk through this. So this gives me 45 minus 13 is 32 equals to 2x. So 16 equals to x, which I usually write as x equals 16. Or this gives me 45 plus 13, which is 58 equal to 2x, which gives me divide by 2, 29. So I get 16 and 29 here. Oh. I'm not very good with the blah, 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 blah. That's right. Why didn't they make a sequel to that? Like, I mean, they make so many sequels to movies I don't care about. Like, they can't make a sequel to Big Hero 6. I mean, I know they got... You cried?
You didn't have to go like that.
What part did you cry? Was it when Takashi or whatever his name is there buys it? Oh, I'm sorry. I'm sorry. Spoiler alert. But at the end. Sorry. All right. Inequalities. Absolute value. All right, so here we go. Let's let B be positive. All right. And I want to point out something. Well, you guys already told me that the absolute value is distance from 0, right? So think about this. If the absolute value of A is less than B, what's that mean? This means that the distance from 0 to A is less than B, right? The distance from 0 to A is less than B. I can draw a picture of this, right? Minus B, B, and 0 is in the middle, right? So where is A? It's somewhere in there, right? It's at most B units from the origin. So what does this mean? I mean, if you look at this picture, I think we can all agree minus B is less than A is less than B, right? Okay, so this gives us the following result. The absolute value of A is less than B is interchangeable with minus B less than A less than B. And this right here is one of our go-to results for solving inequalities with absolute value. You want to use this. This should be on your formula sheet. You need to understand how to apply it, right?
Which one?
What's boxed? The one in the box. What's above that? I'm just explaining why it's true. What if instead of having less than, we had greater than? What if we had absolute value of A greater than B? What would that mean? That would mean the distance from 0 to A is more than b. So if I draw a picture of that, what's that look like? How can you be more than b units from the origin, right? You're either over here, right, further than b units this way, or you're further than b units that way, right? So you can either have a over here, or you could have a over there. Never the two shall meet, right? These are disjoint cases. Either we have a is less than minus b, or we have a is greater than b, right? In other words, we find the following result. The absolute value of a is greater than b if and only if a is less than minus b or a is greater than b. So in contrast to the less than case, these are disjoint cases. So our solution set's probably going to be a union in the greater than case. All right? So what's the standard mistake students make? I mean, I shouldn't tell you. If I tell you now, you're going to make the same mistake, right? It's going to be like a self-fulfilling prophecy, right? Kind of like, well, we've all seen The Matrix. You know what I'm talking about. You haven't seen The Matrix? That's hardcore. See, like I was teaching intermediate algebra, University of West Alabama, and I had a football player.
West Alabama.
West Alabama, that's where I was.
Where are you from?
Not there, obviously, but I mean, if you want to know, Vestal, New York. But anyway, I mentioned Thanos in passing. I know back when I used to care about Marvel movies. That time is gone. But and he's just like, "Who's Thanos?" And I'm like, "What?" I'm like, "You don't know who Thanos is?" And I started probing, and like he had not seen any major like comic book movie that's been produced any time. I don't know. It's kind of like every once in a while you meet somebody who hasn't seen The Godfather or something, and it's just like, you guys probably haven't seen The Godfather. It's old enough, but in my generation, let's say, okay, if you meet somebody who hasn't seen a movie like that, it is they have made a decision. They're going to be weird. They're just be like, no, I'm not watching it. So every time somebody asks me, I can just be like, no. Like if you meet a person who hasn't seen Star Wars at this point, it's like, that's a bold choice.
Star Wars.
What? What's Star Wars? See, once I believed it. Now it's just like, you know. I mean, if you looked more Amish, maybe, I don't know. But
So Star Wars are just stars fighting?
let's see here. What?
Or Star Wars are just stars fighting?
Star Wars is just stars fighting.
That'd be scary.
Wouldn't that be? that would be different, right? My brother says that Star Wars is a movie about space wizards for children. Space Wizards for Children. It's a child's movie, but he mostly says that to offend Star Wars fanatics. Anyway, example. All right, I see you guys have the propensity to distract me like nobody else. How about this? Absolute value of 3x minus 7 less than 2. Can we solve this thing?
Yeah, you know, go to it.
So here's what we do. We go minus 2 less than 3x minus 7 less than 2. So what I'm thinking about here is a equals to 3x minus 7. In this case, b equals to 2. That's my thought bubble here.
All right, you got 1 is 3. Other one is 4.
Now what do I do? Hey, now we're back to last class, right? So now we just add 7 across the inequality.
Yeah, other one.
And that gives us 5 less than 3x less than 9. And now we divide by 3, which gives us 5/3 less than x less than 3.
God bless you.
Um,
All right, so
did you come to 2 classes today? Whoever sneezed? No, because I heard that sneeze earlier today. Like the exact same sneeze. There's a girl in the first section, same sneeze. Is you like a cousin or a sister? No? Okay. Let's see here. What's that? Oh, you're in the first section. I'm talking about like chronological, not like the arbitrary numbering that they use here. I don't know. Yeah, the first section I teach is actually section 2. Then I teach section 3, and then you guys are section 1.
Yeah, we first one, right?
And then, anyway, so here it is, solution set. There it is. Hey, let's.
That was a easy one, come on now.
Okay, here, I'll make it worse.
Make it as worse as you can.
Well, not really much worse. 3x minus 7 greater than or equal to 2.
Same thing.
It is similar, but it is different because
Okay.
it's flipped. So now I have to do this, right? And equals, both of these boxes, you could add equals if you wanted. Okay? Whoa! They did put that there, didn't they? Let's see here. See, I almost wish I'd fall down. That would have made my course evaluations improve.
You don't want to do that.
Students always like to see people fall. It's just funny, right? Like any number of classic situation comedies are based on people falling, you know? I mean, hopefully I wouldn't get hurt, but all right, so here we go. 3x minus 7 less than or equal to minus 2, or 3x minus 7 greater than or equal to 2, using this. Now we need to solve those separately. They're separate problems. I would add 7 to both. And that will give me 3x less than or equal to 5, or 3x greater than or equal to 9. Divide both sides both by 3, we get x less than or equal to 5/3. And here, x greater than or equal to 3. So this one means x is an element of minus infinity to 5/3 included. And this one would mean x is an element of 3 to infinity. So it's either in that set or the other one. We use union to put them together. The solution set, in this case, I'll write it over here, is the union of minus infinity to 5/3 with 3 to infinity. How are these related? Can you draw a picture?
Wait, the sign on the one on the left is flipped. Right? Or not?
Well, let's see here. This is 5/3, right? So like this is from here and from 3, let's say, like that, right? So this would be example 8.
But the other way is like, it's probably like 2 out of 5.
Where's example 7 solution in this picture?
It's the, over there, right?
Yeah, it's right here, right? So what happens when you put these two examples together? You get what? Yeah, infinity to minus infinity to infinity. You get everything, right? Because these examples are complementary, right? Whatever x makes 3x minus 7 greater than or equal to is exactly the x which doesn't make 3x minus 7 less than 2. And vice versa. So like whatever's not in the solution to this must be in the solution to that. Whatever's not in the solution to example 8 must be in the solution to example 7. I often ask a pair of questions on the quiz or test like this. It looks like the same problem, right? But if you look at it more carefully, you notice one is less than, one is greater than. You can use these problems to check each other, right? Just please pay attention. There is a very big asymmetry between the greater than and the less than problem, all right? So we'll do more of these next time, but I guess that's it for today. Wait a minute. Hey, I still got a minute. You guys just start packing up. Any questions?
Is the number line necessary for any answers on the test or what?
Yeah, I do want you to write number lines for the, if I say to use a number line, please use a number line. So yeah. Now, if you happen to have learned like a grid method in your previous class and you know how to do that orderly, I'd also take that, but I think that's a lot more like writing. All right, well, shut it down.